Hello everyone, how are you? Hope you are fine. Today we will talk about how the charging circuit works in a Samsung premium phones. If you understand this charging circuit, then you understand Samsung economy, premium and flagship phones circuit will be simple and easy to understand for you. In this phone, charging IC use SM5713. This IC used by mostly premium phones like Samsung A50, A50s, M31, M30, many models. Now this charging IC work as a sub-power IC also. Now let's start the topic. In this phone you will see a C-type charging port. Now a phone come to you for no charging issue, no connectivity. Now how to check step by step, I'm telling you in this video. First, front of you there is a charging sub board. First, when you connect the charger, you can check here in this charging connector 5. If you get 5 volt here, then it's okay, no need check to the subboard. Otherwise, first working on a C-type port, second solder this connector. If you get 5 volt here, then through a flex cable, this Vbus line or Vbus voltage comes to the main motherboard charging connector. I will show you. This is the main board, main motherboard. This is the main charging connector. You will get 5 volt, this line, Vbus line. In this line, you will get 5 volt. If you did not get 5 volt here, then work on a charging flex cable or charging port. Now open the schematics. First layout, copy this connector and paste it in schematics diagram. Now you can see this is the main charging board motherboard connector. Right here, I'll find the Vbus line first. Now you can see there is a Vbus line, Vbus IF5 volt. Click it and next. Now this line goes to the first O. So this is our OVP IC, over voltage protection IC. This line goes to the OVP IC, right? So just copy it and paste in layout. See where it is installed in our motherboard. This IC. Copy this IC and paste in layout. See where it is installed in our motherboard. U6002 OVP IC. Paste in layout. You can see here there is 6002 near the CPU UME5000. This is our CPU U5001. This is our charging IC. Right slightly above the charging IC here OVP IC. Now back to the schematics. I have already told you about OVP IC in previous video. How OVP IC work, how to bypass it. But the circuit in this phone, it is little different. So I am telling you again about OVP IC. Clear? Now this Vbus line goes to the OVP IC. Right? You can see here this Vbus line goes to the OVP IC, just like the another phone. But the difference is this Vbus line goes to the OVP IC, but there is another line coming out whose name is Vbus discharging. You can see here this line called Vbus discharge just before the OVP IC. Clear? You hardly know about this line. So let me tell you about this line. What is this line? How this line work? You can see there is 3 resistance, 2 resistance in a series and 1 resistance in a parallel, 2 resistance in a series and 1 resistance in a parallel, being made a divider circuit with a along with a MOSFET. You can see here a MOSFET along with the divider circuit, Vbus and divider circuit output line, Vbus discharge. Click this line and see where is this line going. Click it and next. Now this line going to the GPIO section, general purpose input output section in CPU or master IC. So this line goes to the CPU on GPIO section. Now again next, now this line back to the same IC near the OVP IC, same line. That means this line connected between the Vbus line and directly connect to the CPU. Now let us know what is this line does. Right, in this line you get 5 volt from charging connector to OVP IC. You get 5 volt. Also same 5 volt you get here. You get 5 volt here on this line through divider circuit. This line goes to the CPU. So according to my experience, in this line you will get 1.8 volt maximum. In this diagram you can see no value written on resistance, any resistance. In my experience, this line maximum output on 1.8. Through this line CPU sense. Now if any shorting on this line, CPU sense through divider circuit line, Vbus discharging line, divider circuit output line. Clear? After CPU stop working this line through MOSFET, this MOSFET working as a regulator. Clear? By when excess voltage on this line or any shorting, CPU regulate through MOSFET, ground the voltage. Clear? Or stop working this line or save the circuit. Clear? So this is our protection line like OVP, another protection for circuit, high voltage and shorting, direct control by CPU. Now you understood this line, what this line does, how this line work. Clear? Now this line goes to the OVP IC. OVP IC means over voltage protection IC. If any excess voltage from 5 volt to any access, suppose in this line any chance 7 volt or 8 volt. First CPU sense, after OVP IC. So OVP IC open itself like a fuse or save the main motherboard. Clear? If by chance any pulse on high voltage cross this line, OVP IC open itself like a fuse. So you can bypass easily OVP IC. Mostly fault in, you can say, in charging section. How to bypass OVP IC in an easy way? First you check this capacitor. On this capacitor you check 5 volt here. If you get 5 volt here, after you check this capacitor after the OVP IC for 5 volt. If you get 5 volt here, that means your OVP IC will be open. If you don't get 5 volt here and you get 5 volt on this capacitor, that means your OVP IC is faulty. Clear? So just take a jumper from this capacitor positive to this capacitor. Your OVP IC will be bypassed. For this, just copy this capacitor and paste in layout, so you can find out easily where this capacitor placed. Near the OVP IC, you will find near the OVP IC both capacitors. But in case this jumper you did not remove OVP IC, direct take a jumper from this capacitor to this capacitor, positive to positive. One side capacitor positive and another side capacitor ground, because capacitor used in a parallel line, these capacitor, right? Now in another way, you just remove the OVP IC and you can see B3 and A2, these pins, you just take a jumper, small jumper between them, any one of line, your OVP IC will be bypassed. After that you get 5 volt here. Most of the cases your OVP IC is faulty because of the voltage fluctuation. This IC used for protection, that's why it's open itself like a fuse. Clear? Now first we draw on a block diagram so you can easily understand. In front of your screen there is a charging connector. A line comes out of it and goes into the OVP IC. Clear? This line called Vbus line. Another line emerge from Vbus line going to the CPU. This line called Vbus discharging line. I have explained to you about this line in a schematics. I have just explained to you about this line in schematics with 3 resistance forming a divider circuit. Also connect with the MOSFET. MOSFET works as a regulator. Through this line, CPU sense. If this line had short, CPU deactivate this line through MOSFET. CPU regulate this line through MOSFET. If anything wrong, shorting in this line, CPU ground all the voltages through MOSFET in this line. Clear? I have just given you all details in schematics in complete detail. How this line works, how to check OVP IC and how to bypass it. Also, what is this line, how this line works, Vbus discharging. Now get back to the schematics. Now you can understood these lines, Vbus 5 volt, also Vbus discharging. A line goes out from the OVP IC, the main line, and going to the two sides. One is the Vbus 5 volt OVP, another is Vbus short. This is our main route line, but this line is new for us. Most of the company don't use this line. Now what is this line, how this line work, I will explain to you. For this, just click this line and next. Now this line goes to the AIC. Which IC is this? U5001. This is our charging IC. Now this line Vbus short connected to the charging IC directly. Now it means that OVP IC to charging IC. How this line work, what it does, I will tell you. This line use as a protection, like Vbus discharging line. This line same working. This line Vbus short. If any shorting on this line remained, charging IC sense shorting through this line and deactivate itself. Clear? This is also our protection line. Click this main line Vbus 5 volt OVP and next. Now this line also going to the our charging IC with a inductor, L5007 inductor, also a capacitor. Now this line connected to the J6, J7, K6, K7 Vbus line to the charging IC. Now let's draw it first. A line goes out the OVP IC and connected to the charging IC called Vbus short. Through this line, charging IC sense shorting or not on this line. Now another line or main line connected to the charging IC we can call Vbus line. Now look at the charging IC, right? There are many lines coming out of this IC. Many technicians get nervous after seeing this IC. So many lines. They're thinking about these lines, how these lines work, how the circuit works. After that, technician confused and mind does not work. After they close the schematics or open the YouTube videos for direct solution or hardware solution if they have a margin like software. But many times YouTube videos or hardware solution does not give proper solution or success. So in last, phone is not repaired. After, return the phone to the customer or go to the another technician and get the phone repaired by him. After that, give the phone to the customer. Why this phone not repaired by you? Because the lack of knowledge, lack of schematic knowledge. First I will show you what is the difference between hardware solution and schematic. Now let me explain to you why you should know how to read schematics. So let's compare hardware solution and schematics. One side I'm opening the hardware solution in charging data. If any phone come to you, most of the technician use hardware solution, open the charging data. In hardware solution they follow Vbus. First they check 5 volt here on mainboard connector. After the follow this Vbus line, this reddish color line, right? Now they follow Vbus line. This line first goes to the OVP IC, this OVP IC, right? Now first capacitor, after the same line goes to the OVP IC, right? After that goes out the OVP IC and enter the charging IC. Clear? Now if you want the bypass to the OVP IC, just take a jumper from this to this. Your OVP IC will be bypass. Same as I explained to you in schematics. Now see the difference between these two here, hardware solution and schematics. A one line Vbus line. In hardware solution, only a Vbus line goes to the OVP IC after the charging IC. Clear? But in schematics, you will see in this IC more than 20 pins only regarding to the charging. On other hand, in hardware solution, if you see just in charging IC, maximum 5 lines. On schematics, minimum 20 pins or 20 lines you can say. That's why I say how important it is for you to have a schematic knowledge. Now see here, before the OVP IC there is another line called Vbus discharging. Now this line connected to the CPU. I'm already explained to you in this video. This line connected to the CPU. Through this line CPU sense any shorting or voltage fluctuation. I mean CPU control this line through this MOSFET. Now another line after the OVP IC called Vbus short. This line connected to the charging IC directly. Through this line, charging IC sense shorting or any voltage fluctuation or anything wrong. Clear? I will explain to you already in deep how these line works. But in hardware solution, you can see there is no line before OVP IC connected to the CPU. This is our CPU. This line is DP. You can say bad thermal line, sorry. But there is no line on a charging circuit called Vbus discharging. Also no line after the OVP IC connected to the charging IC called Vbus short. So that's why if you follow only hardware solution or direct solution on YouTube videos, your phone will not be repaired. If you have schematic knowledge, then you will find the fault in second or third step. Clear? If you have a schematic knowledge, and according to schematic knowledge, if you follow first step, second, third, if fault on Vbus discharging line, your third step you will find the fault, whether your fault on resistance or MOSFET. After that you feel a different happiness. You did the work on proper way. This solution did not happen by any chance, right? Now on the coming time, circuit are becoming very complex. If you don't have a schematic knowledge, you won't be able to do anything, because you can see in back if one charging IC or one power IC installed on our phones. After that 2 charging IC or you can say 2 power IC. Now in latest 5G phones, 5 charging IC. If you don't have a schematic knowledge, how can you repair? Clear? So update yourself always. If you want to continue this line, mobile repairing field. Clear? Now back to the topic, how Samsung charging IC work. Click this line and next. Now this line connected to the J6, J7, K6, K7 called Vbus line, right? Another line from this connected to the C10 pin called MC Vbus. Draw it first in block diagram. After I will explain to you how this line work. Clear? Now this is a block diagram. Another line called MC Vbus connected to the charging IC pin number C10. MC Vbus means major current voltage bus line. Through this line, charging IC sense how much current on Vbus line, because charging IC need a good current for high speed charging. If this line open, right, then your IC does not work properly. Next line called MID Vbus or MID path. Both are same. Now in this line, you will get one capacitor 5051. Copy this capacitor and layout and you will find the position. In this line, you will get 5 volt because a MOSFET connected between Vbus and MID Vbus. So you will get 5 volt here on this capacitor. If you don't get here 5 volt, that means your Vbus line not connected properly into the IC, all pins, or your Vbus line had a problem, open or short. So check the Vbus line. If you get 5 volt here on this capacitor, that means your Vbus line from charging port, C-type charging port to charging IC connected properly. If you get 5 volt on MID cap. Clear? If you don't get 5 volt, first check the Vbus line, OVP IC, after replace the charging IC. Now, if by chance this cap is missing or removed, someone remove this cap, thinking short, your phone going to fake charging. Clear? Now draw it on block diagram. This is MID cap, a important cap for filtration. Now get back to the schematics. We read LX. Now a question come to your mind. Why we did not read on right side lines like VDD, VDDF, VDD LED, CC1, CC2, SBU1, SBU2. Why direct LX line? Because schematic always read according to the circuit and circuit always according to the direction. You will always read schematic according to the circuit, how circuit works step by step, not on this. This is just a diagram, or you can say which line connected which part. But if you don't have a circuit knowledge, you don't read schematic. Now let's talk about next line called LX line. Right here, LX. LX means switching line. In Qualcomm we call switching. Also in MTK, MediaTek we call switching. But in Samsung, in switching line LX, that means switching line. Clear? This line connected with H3, J2, J3, K2, K3. This 5 pins, a line goes out called Vsystem, means Vsystem. In Qualcomm, this line called VPH. In MTK, Vsystem. Also in Samsung called Vsystem line. Clear? This line goes to the power IC. Also other section like network, audio, graphic, light, Wi-Fi, Bluetooth. Every section needs main power or main voltage. This line connected to the every section who needs main voltage, because this is our primary supply. This is our primary supply. So primary line connected to boot every section. In this line you will get 3.7 to 4.2 volt. Also in this line you will see a coil, switching coil, also a cap, heavy value cap. This cap connected on a series. One side connected on this line, other side connected with the IC pin number G3 called boot. So this is our boot cap. I'm already explained to you in previous videos all these things. Now boot cap we also call BTST, bootstrap cap. In this cap you will get one side 3.7 volt to 4 volt, on other side 7 to 8 volt. Right? Now a MOSFET inbuilt in IC combined with this coil, also this capacitor, creates switching together with ground on microseconds. After this line, on this line you get a high ampere. That's why switching create for boost this line to high ampere, because power IC need high ampere because power IC produce LDO voltages to every section. Clear? You understood VPH coil, boot cap, any of one damage or open. Suppose this VPH coil, if you did not get here 3.7 to 4 volt, or this coil open or damaged, your IC did not switching or your phone dead. Also this boot cap open or someone change with normal cap. So you did not repair this boot cap. If you check here, one side 3.7 to 4 volt, on other side 7 to 8 volt. That means your IC is switching properly. Otherwise, replace this boot cap. Now, in this line, another line you can see called V ampere VBAT cells. Also, this line goes back to the same IC. First, we draw. After, I will explain to you these lines. Now, you can see here on a block diagram, this line, a reddish line, goes out from charging IC with a coil, boost coil called Vsystem coil, and this line is Vsystem. Goes to the power IC also. The other section I'm already told you, like power IC, graphic IC, light IC, Wi-Fi, Bluetooth. Clear? Network section. Now a capacitor connect on this line, other side capacitor connect to the G3 line on this IC, charging IC called boot cap. In this line you will get, in this cap you will get one side approximately 4 volt, other side 7 to 8 volt. After the switching, this line get high ampere. After this, same line and goes back to the same IC or charging IC called Vsystem. So this Vsystem line also, this line also called Vsystem. I will show you in schematic. I already explained to you. Now get back to the schematic. This line, talk about this line. This line called, from this line goes back to the same IC called Vsystem. Now if you understand more from these lines, you can go to the previous videos. I'm already explained these lines. Switching line, boot cap, what is VPH coil, what is boot cap, how switching create, what is Vsystem line or VPH line. Just go and check the previous videos. Now another line, which you can see here, amp VBAT sense. Now this line connected to Vsystem line. Now where is this line going? Just click it and next. Now this line goes to the AIC. So this is our audio amplifier IC. How this IC work, I will explain to you another video or upcoming chapters. Right? First I will draw, after I will explain to you. Now another line emerge from Vsystem line. Another line, this line emerge from Vsystem line and goes to the amplifier IC, audio amplifier IC. This line called VBAT amp sense. This is the main voltage from amplifier IC. This IC amplify your main speaker, your sound. You will see another line goes to the battery connector. This line called charging out. After this line goes back to the same IC, a MOSFET on this IC connected to this line, also this line. When you connect the charger through Vbus line, your phone create Vsystem line. Also through this MOSFET charge the battery same time. But when you disconnect the charger, battery power, this MOSFET reverse the work. So battery power goes to this MOSFET reverse working and gets supplied to, I'm explaining to you. When you remove the charger, clear, battery power goes to this line and through MOSFET, this MOSFET now reverse working, power to this line, and this line create Vsystem line and goes to the power IC or all other section. Now your phone runs on a battery. Clear? When you connect the charger, your phone runs on this way on Vbus line. But when you disconnect the charger, your phone runs on this line. Now get back to the schematics. I will explain to you charging out line. Now this line goes to the battery connector. You will see in diagram. So just click this line and next. Now you can see here this line goes to the battery connector HDC 5000. So just click it and paste in layout. So zoom, you can see here, this is our battery connector, this is our charging connector, this is our battery connector. I will show you in hardware solution. So you can see here, this is charging connector. Also in hardware solution, I will explain to you this line. This is a boost coil, Vsystem coil. Clear? A line goes out from this coil and get back to the power IC, goes to the power IC. Also other section called VBAT system right here. But in hardware solution, it did not show on boot cap. Clear? Another line through this here MOSFET, another line goes out. This line, this red color line. Now follow this line. Now this line called V battery. Same, I will explain to you schematic. On this line goes to the battery connector positive. Here, now in schematics, now this line from charging out to battery connector to charge the battery. Here, now you can see here another line V battery with a divider circuit called VBAT ADC. Now this line not shown on hardware solution, but in schematic, how this line works, I will explain to you. On a battery connector, a line connected to two resistors creating divider circuit. One resistance connected with the battery connector, also another resistance connected with the ground. Now what is divider circuit? How divider circuit works? I will explain all the details of how divider circuit works. So go and check out this video. Now I will explain to you this line VBAT ADC. So just click this line and next on this line VBAT ADC goes to the our CPU Exonix 9610 9610. This is our CPU. Clear? From battery connector with a divider circuit, this line goes to the CPU. Now first I will draw, after I will explain to you. Now this is our battery connector, a line connected with charging out line, right? From charge the battery, another line connected with this line and goes out to the CPU called VBAT ADC. Now the output line emerge from between the divider circuit R1 and R2. R2 connected with the ground, this capacitor, right? R1 connected with the main line, voltage battery line. Clear? So in this line you will get here 3.7 to 4.2 volt. Clear? But in this line you will see different voltage because divider circuit here. Now I will explain to you. Now VBAT ADC means voltage battery analog to digital converter. Voltage battery analog to digital converter. On VBAT line you will get 3.7 to 4 volt, minimum 3.7 volt. Through this line CPU measure how much battery current at this time, or you can say charge at this time. After this CPU convert this data to digital to show the display. I mean from 3.7 to 4.2 voltage convert it to digital and percentage. Now after this you can see on battery symbol 10% battery, 12% battery, 50% battery, 98% battery. Through this line CPU convert analog to digital. How? I will explain to you. Suppose in this line you will get 3.7 volt. Suppose in this line you will get 3.7 volt. Now 3.7 volt means battery low. 3.7 volt means battery low. But how CPU know battery low? Now in this line you will get 3.7 volt. Clear? So on divider circuit you will